So prior to this chapter, all of our objects have been relatively simple. We've been able to describe each one with just a simple class: triangle class, a pet class, a rectangle class, circle class, a book class, and so on. But for an object that's more complex, you should consider breaking up the object into its constituent parts and defining one class as the whole and the other class as parts of the whole. So for example, not that I'm going to actually do this in NetBeans, at least not at the moment, but I could have. I just want a text window, gang. Don't, oh, excuse me. All right, so in the past, we have been, just doing a class that had some kind of primitive data types in it or strings in it, maybe several different ones, but all basically pretty simple classes. But we might want a class that was a point class, which I know we've done before, right? You might have a point class, which contains an X, Y, and a Z coordinate. And then when you define your triangle, it's a collection of 3 points, right? Because that's all a triangle really is, right? X, Y, and Z coordinates in 3 space, or at least if it was in 2 space, you could have X and Y, right? So you might have a triangle class that has 3 different points, right? Are they called vertices? I'm not sure. Point V1, V2, V3. And so each one of these members is a point. All right, you're still there, I think. Yep.
I'm still here.
All righty, great. Okay, so this is called composition. Composition is when you use classes to make up a class. Although really, I guess it's composition if you just have, individual primitive types. Anyways, composition is including data types inside another data type. For an object that's more complex, you should consider breaking it up. When the whole class is the exclusive owner of the parts classes, that class organization is called composition. So our triangle, is each point exclusive to the other ones? Yeah, maybe so. We might have 3 points that's owned by one triangle and 3 points that's owned by another one. And it's possible maybe that those points have the same values, but we'd probably consider them, separate points. But what if you had an employee class and each employee had a department, but in your department class, the department could be shared among more than one employee class, right? Now I was kind of arguing with myself whether a point could be shared between more than one triangle, and I guess realistically it could be. But each employee could have either a separate department or you could have several different employees that were all part of the same department. That's called composition if they are unique, and it's called aggregation if some of the parts are shared among multiple other parts. So composition, the class is the exclusive owner of its components. Aggregation, components are shared between objects. I should say the object is the exclusive owner of its components. So composition. The concept of composition is not new. It's how we describe objects in the real world. Every living creature and most manufactured products are made up of parts. I have a car and it's got an engine and it's got 4 wheels, it's got a stereo. Each one of those is a subsystem that is itself made up of its own set of subparts. And then it forms a composition hierarchy. Note that the human body composition hierarchy on the next slide. So a body has got a brain and a heart and a stomach and the bones, and each one of these has got subcomponents, right? Muscles have cells. Cells have nuclei. Got also got mitochondria, which are composed of molecules, which are composed of atoms, which are composed of quarks, whatever. However, you probably would not want to describe a human body based on its atoms for the most part. But so notice that what they're doing here is they're saying that we have a human class and then a brain class, and the human body owns the brain class. And it's an exclusive relationship. We don't share the brain among multiple human bodies. And so they use this little filled diamond to indicate that. If the diamond is white rather than filled, it means it's an aggregation where you could have a brain shared between more than one human body. So aggregation, the relationship between a containing class, or wait, in a composition. Compositions are considered has-a relationships. A human body has a brain. A human body has a heart. A human body has a stomach. Human body has bones. A triangle has points, right? So that's a composition relationship or aggregation. An employee has a department, right? So that's a composition relationship, composition or aggregation. There's another form of relationship called aggregation, which is a weaker form of composition. I'm not sure why they call it weaker. With aggregation, one class is the whole and other classes are parts of the whole, but there's no constraint that requires the part to be exclusively owned by the whole. In other words, they can be shared between multiples. An aggregation where the parts are not exclusively owned by the whole. You might have a class for the school and then part classes for the different types of people who work and study at the school. You might have employees and you might have students, but what if you have work study students, right? And they're both employees and they're students. So they could be shared between both types. The people aren't exclusively owned by the school because a person can be part of more than one aggregation. A person could attend classes at two different schools and be part of two school aggregations. The same person might even be part of a third aggregation of a different type, like a household aggregation. So you could have a class, a course, and it could have a list of students, right? Then you could have a second course, and it might have, student 2 and student 4 in it. Again, this is kind of a composition relationship. It's a has-a relationship. Each course has a student or multiple students. These students can be shared between multiple courses, so it's aggregation, not composition. Let's say that each class has its own room, right? Room 231, room 232. Again, a room may be shared by more than one course. So that is another aggregation. Car dealership. Going to have a car class, a manager class, and a salesperson class. And then a dealership, which uses those three part classes. Here's a relationship. A dealership has cars, multiple cars. That's what the asterisk down here means. It's a one-to-many relationship. Every dealership can have one or more cars, but the car is owned only by one dealership. I'm not really sure what the one is here from. Ignore that. I'm not sure what's going on there. But we're saying that the dealership exclusively owns the cars. We don't have the same car sitting on multiple dealerships. So it's a one-to-one relationship. Well, it's not a one-to-one, but it's a composition because the car is not shared among dealerships. However, the dealership has a manager, one manager per dealership, but since it's a white diamond, this manager could work for multiple dealerships. I guess my brain is fading on the purpose of these numbers here. And then lastly, the dealership could have multiple salespeople. That's what the asterisk means. It can have more than one salesperson per dealership. And this salesperson could work for more than one dealer, right? He could work at one during the day and one during the night. So again, that's an aggregation relationship. This is a UML class diagram. It doesn't look like the UML we've done in the past, but it does have these lines between them. And that's another factor in drawing UML diagrams. If we wanted to, we could make this an entire UML diagram that had the class name and the data in a separate block and then the methods in the third block. But right now we're just kind of showing the hierarchy, the structure. That's a lot of, there are different ways that classes can be related. We've covered aggregation and composition, and then there's inheritance. Inheritance is an is-a relationship rather than an has-a relationship. You might have a vehicle class, and then you might have an automobile class. An automobile is a vehicle. An airplane is a vehicle. A tiger is a feline. A house cat is a feline. Feline, not feline. Well, let's go ahead and do the aggregation, excuse me, the composition idea. I don't feel like demonstrating aggregation in code, but I do feel like demonstrating. And let's just go ahead and do that a point class and then a circle class that uses the point class as its radius. Or we could do the triangle, or we could just do a line. A line is defined by 2 points. If we remember our geometry. I have absolutely no recollection of what lecture we're on. Lecture Q, is that it? I'm not sure if that's ours or the other one.
We did Q, we're on R.
All right, elemental P, Q, R. So we're on S, we're on?
We're on R.
Okay, so we're doing an R, all righty. Not gonna do anything special with graphics, so we definitely wanna make a main class. All right, so as part of our class, let's make a point class, which has got an X and a Y coordinate. Except I'm going to call it P point because I remember from bitter experience that Java also has a point class that if we name it the same thing, we can get in trouble. So this is class P point, which has got a X, and let's make them doubles. And let's add a constructor for it. Public P point int X comma Y, set this dot X equals X, this dot Y equals Y. Why are you complaining? Oh, derp. You can't do that. And I kind of wish you would. Each variable has to have its own type descriptor, right? There we go. And then we can make a line class. And a line is described in geometry by 2 points. And it's the point, it's the line that connects those 2 points. If it's a segment, it only goes between those 2 points. But if it's a line, it extends infinitely. I guess we could just call it segment. That's probably also a secret, a keyword anyways. And so it's going to have 2 points. P point, P1, comma, P2. Capital P. And I guess we should make a constructor that accepts those points. So public segment P point P1 comma P point P2, and this dot P1 equals P1 semicolon, this dot P2 equals P2 semicolon. I'm kind of questioning my design decision here. I might want a set P1 and a set P2, which would set the coordinates for the points. Instead, we're going to have to create these things. Yeah, let's add a generic constructor, a default constructor that doesn't do anything. Come on. There we go. Oh, and have I locked up my machine? Nope. Need my parentheses there though. Sorry. Still not familiar with my laptop keyboard. All right. And now a set P1 and a set P2. So public void set P1, which is going to take an X and a Y value. And it's going to create a new point. So P1 equals new P point, parentheses X comma Y. And I'm just going to do the same thing for point 2, right? So let me copy that and paste it. And if you're typing along and you need me to slow down, that's totally fair to jump in and say, yo, slow down. So this is just P2, P2, and P2. I think that's going to be easier to use than this. Or I could make this say int x1, y1, int x2, and y2. Yeah, let's do that. I'm going to go back to my constructor and make this say int x1, comma, int y1, comma, int x2, comma, int y2. And then it can just call set p1 with x1, comma, y1. And then it can call, that was supposed to be a semicolon, thank you very much. Then it can call set p2. And it's going to give me a warning about being a bad programmer for calling methods inside my constructor. I'm going to ignore that warning. Its solution is to make the class final. Not sure why I would do that. That would mean that the data is supposed to be constant. But we could probably want to change it. Make the method set P1 final. Why would we want to do that? It changes it. I don't see, I'm going to have to research what that would do. I do know that if I made this a final class, it would mean that the data is not supposed to change. And I guess that would be a fair thing to do, right? But then what if they call set P1, you know, and change it? So I'm not digging that. I'm going to remove the word final. Okay, so that's my class. This is a useless constructor, so I may just get rid of that one. What do I mean it's useless? Well, I guess it's not, but it'll create an object that has no P1 or P2 value. And so conceivably, I should create 2 points that are just set to 0, 0 and 1, comma 1 or something like that. Just some kind of default data so that if we ever call any functions on it, it'll be okay. So set P1 equal to 1, comma 1 and set P2 equal to 2, comma 2. Just have some kind of default data. Could set them to 0, 0, but then it's not a line segment, is it? Now this would work if we made these private so that the calling class, the client class, could not call them, then we could make this a final segment. So now the calling class cannot create its own points and set them. They have to be created when we create the constructor or when we construct it. And in that case, yeah, that fixed his errors. He's no longer complaining about that. Why did I make those final? I meant to make them private, and that's not going to fix the errors, but it will if I make the object final. Oh, he says that is fixed. Anyways, I'm going to do that anyways. Once you create an object, its points are fixed. They're not changing. All right, so down in our lecture, down in main, we can create 2 points. Or not a point, we can create a segment. Segment S1 equals new segment. It starts at 0, 0, and it goes out to 10, 10. All righty, we got multiple people here. Excellent. Abraham, do you need me to scroll up and down, or are you just going to watch without typing anything? You're all good? Okay. All righty. So let's create our segment. There we go. Now, what are we going to do with a segment? I don't know. We might calculate the rise over run, right? Or we might calculate the distance of the points. I don't even know that I want to do that. I don't even know if I want to create some purpose for this thing existing. But we have created a class that's composed of other classes. And each class owns these points, so that it is definitely a composition. A segment has points. It's got to do something. Let's make a toString method at least, right? Public string toString return string.format parentheses quote segment parentheses %f comma %f in parentheses open parentheses %f comma %f close parentheses close quote comma p1.x p1.x comma p1.y p2.x p2.y. Right. I think I'm just to pretty print it. I'm going to add a parentheses there and a parentheses there. So to calculate the slope, that's just rise over run. I don't know what the slope is if it's a vertical line though. I don't feel like handling that. So I'm just going to make a toString method so we can print it out. At least we've demonstrated composition, even if it's not doing anything useful. So let's create a second segment. Segment S2 equals new segment, calling our default constructor. And let's print out each one. System.out.println S1, system.out.println S2. And I see a typo here.
What was that?
My brother took the truck and got it cleaned today and said he didn't think it's ever looked that good.
Oh, that's rough.
So when I ran it, there we go, right? We have 2 segments, one that goes from 0, 0 to 10, 10, and another one that goes from 1, 1 to 2, 2. That's an is-a relationship. Excuse me, that's a has-a relationship. How about an is-a relationship, where we're showing a connection between 2 different things? Well, let's say that we've got something called species, and then we have some subspecies like feline, and then we have some subspecies that are felines. So coming down here above main, let's give an example of that. Class, let's just call it animal. And above all, every animal has a name. String, oh, come on. Thanks. String name. If I could disable my trackpad, and I know that I can, if I looked, I would be happier. That's enough. Or, you know, really, I guess genus is what they're called, right? Every species has its own genus. There, now we're all fancy. Now we have a class called feline. Which is an animal. So it extends the animal class. Extends animal. I'm going to change that back to name. Every animal has a name, right? And every feline has, well, I don't know what it has that's unique, but it has some methods that are unique because every cat can purr, right? Not strictly true. I don't think lions purr. Let's just go with it. Public purr. Actually, I am fumbling with this, and I've done this example a lot, and so I'm not sure why I'm fumbling with it. Tell you what, I'm going to revise it. We have every animal could have teeth, 0 or more. And every animal can have legs, 0 or more. And then we have a class called cat, which extends the animal class and then has its own additional capability, right? So every animal can eat. So it needs a method called eat. And what it can do is just print, I'm eating. That's all it needs to do. System.out.println, I am eating. So the animal, the cat class has its own unique ability to purr. Public void purr. System.out.println, I am purring. It hung again. All righty, there we go. That was supposed to be the word println. I feel like making it say printf so that I could say I am eating and instead change that to %s so that it can print out its name, right? So %s is eating, you know, Ralph is eating, Felix is eating, and so on. I'm going to change this one to printf as well so that I could do %s is purring. Now, when a cat is created, it needs to set its name and its number of teeth and its number of legs. So let's do that. Let's add a constructor that sets these values. So public cat, and it's going to accept the cat's name. So string name. This needs a constructor that'll accept all this information, right? So we need an animal constructor. So public animal that accepts a name, a number of teeth, and a number of legs. So this dot name equals name, this dot teeth equals teeth, and this dot legs equals legs. The constructor for the cat needs to call this constructor and pass in the name and then the teeth, and then the legs. Kind of contemplating adding a value called species so that we could pass in that, Felix was a cat. I guess maybe that'll be the name. No, I want to do that. So I'm going to add a string called species. And that's going to be one of the things that we pass into our constructor, right? Every animal has a species. So string species. And we need to set that as well. This dot species equals the species that was passed in. So this constructor does the heavy lifting. The constructor down here for the cat class is just going to be pretty simple. It's going to call the super constructor. The super constructor is a constructor that's the super class. The super class is the one that's at the top of the hierarchy. We have an inheritance hierarchy. We are inheriting from animal. That means that cat is a subclass and animal is a superclass. Now, super doesn't mean that it's more big and powerful and stuff, because it's actually the subclass that's got more powers, because you get to list the things that the subclass does that the superclass couldn't. So anyways, we have our constructor here. What's that? Constructor required. We need to call our super constructor. And we're going to pass in the species, which is feline, comma. We need to pass in the name of the cat. And every cat has 20 teeth. I'm making that up. And every cat has 4 legs. Now I can make another animal, right? A dog. A dog will also extend animal, and it'll look very similar to this, except its constructor will be a little bit different, and it'll have a different, ability. Bark, not purr. Being incredibly lazy, I'm just going to copy this and make those changes. So this is a dog. His constructor is called dog. A dog is a canine. He doesn't purr, he barks. So bark, %s is barking. I guess purring has 2 R's, so I need to make that 2 R's up there. All right, let's create some animals. Dog D1 equals new dog, Lassie. Cat C1 equals new cat, Felix. Both kinds of animals can eat. Dogs can bark but not purr. So if I type d1.purr, that's not going to work. It's not an existing method for it. All cats can eat, because every animal can eat. But cats can purr, dogs can't. Oh, and I messed up something with a print formatting exception. Oh, I forgot to feed in the name here. So %s is barking. Who is barking? This dot name. And obviously I made the same mistake with the cat. So I'm going to have to scroll back up and change my purr method as well. And here we go. I forgot to put some \n's or something in there, but Lassie is eating Lassie is barking. Felix is eating. Felix is purring. Let's go and add our \ns, and then that example may be done. So since these are printf, printf doesn't automatically go to the next line. So I had to add a \n to the bark method and to the purr method. Now, if we wanted to make it more generic, maybe we could make a method called makeSound, and then we could override makeSound with purr and bark. What do I mean by that? I could say that every animal can make a sound, but then we're going to customize the makeSound method for both kind. So change that word purr to just sound. Change the word bark to just sound. Come up here and create a method called public sound, public void sound, and let's just print %s is making a sound. \n, end quote, name, parentheses. And it looks like here's another place that I should have added a \n. So why am I doing this? Because now I can make every animal do a sound. And a while back, we did a lecture about interfaces. If I wanted to, I could mark this as being mandatory. Every class would have to have a sound. But that's an interface, not an inherited superclass. They are very similar. But let's go ahead and modify our thing down here so that instead of calling that, we call sound. Instead of doing that, we call sound. So let's make an array of animals and stick our dogs and our cats in it. Animal A list equals new animal, and we just need room for 2. And A list subscript 0 is equal to our dog. A list subscript 1 is equal to our cat. And we're going to make a for loop. So for animal AA colon A list, for every animal in the list, make that animal eat, make that animal make a sound. I'm going to comment these guys out because we've already proven that that worked. So you see what we did? We used the superclass as the type of our array so that we could store both cats and dogs into it. And when we print out eat, every class, every cat and every dog share the same eat method, but each one has its own custom sound method, either for purring or for barking. Right? And so Lassie is eating, Lassie is barking. Felix is eating, Felix is purring. This is called polymorphism. Polymorphism is when you can treat objects as though they are the same, but then they exhibit different behavior. Right? We're telling the animal to make a sound, but each animal can have its own unique sound. It's behaving differently, even though the function calls look the same. Poly meaning many, and morph meaning shapes. We are treating all these different classes as though they are the same type. The only way that works is if, when we're using a generic like that, is if they are all defined as part of the superclass. If I add some special method to the cat class, I don't know what, I'm going to wind up deleting this. So if you happen to be typing along, don't do that. I can't come down to the cat class. Excuse me, I can't come down here and say AA.special. Why? Because that dot special method is part of the cat class. It's not part of the animal class. Now, it's conceivable that you could cast this animal to being a cat, but what if it was a dog? Then casting it to a cat would be a bad idea. It would generate an exception. So you would need to check to see if it is a cat, and then you could cast it to be a cat. That's a lot of trouble. So we're not going to implement our polymorphism like that. We're going to implement our polymorphism by having all the methods that are in common be declared in the superclass. So I'm going to get rid of that one. So let's add some notes. Superclass is the class at the top of the hierarchy that is inherited from. The subclass is the class that inherits the superclass. In this language, inheriting is called extending. In this language, inherit is called extend. So I should be using the word extend. The superclass is the class that gets extended, and the subclass is the class that extends the superclass. I guess I'll change that. A subclass has all of the abilities, all of the properties and methods of the superclass plus more. That's why it's a different class. It's been extended. One class can extend another, which can extend another, can extend another. So like, what if I had a very specific kind of class, right? I could make a Persian class. Persian is a type of cat, and it extends the cat class. So now we have one class that's extending another class, which is extending another class. The cat class is the superclass of the Persian class. The Persian class is the subclass of the cat class. And then way up there, we see that the cat class extends the animal class. So the cat class is the subclass of the animal class. The animal class is the superclass for the cat class. Now this is giving me an error probably because it wants me to create a constructor. There, I created a constructor just by clicking on it. Now I'm going to delete all that, I think. I guess I could leave it there. If I am going to leave it there, I would want to cut it and move it up above main along with the rest of these. And really every class should go in its own file, but by now we would have, 8 or 10 files attached to this project. So I'm just going to leave it as is. So in our example, these are all examples of is a relationship. A dog is an animal. Animal. A cat is an animal. A Persian is a cat, right? And then we have has a relationships. An animal has a name. An animal has a species. I'm pretty sure that I probably have genus and species confused, and I'm certainly not going to bother figuring out the correct terminology. I hope it's clear enough. Been a little bit too long since biology for me. So I hope that kind of makes sense. One thing to note is that here we have a method with the same name as the method in the superclass. That's called overriding. We can add the override notation, and we've done this before when we were doing an interface or when we were adding toString, right, and dot equals and things like that. And we could go back and we could do that to cat as well. And I've explained in the past why the @override notation is a good thing. The reason it's a good thing is that if it turns out that I thought I was overriding something and I really wasn't, I would want to know about it, right? So now this is an invalid override because there is no method in its superclass called sound with an extra D at the end. So an inheritance overview, creating a more specific blueprint that's based on the existing master blueprint is analogous to the concept of inheritance in which a new class is derived from an existing class. Derived is the same thing as extending, right? We extend the animal class with cat. Cat is derived from animal. It's called inheritance because the new class inherits, borrows all the features, the data and methods of the existing class. I think I called it abilities in my notes. I should probably rename that to features. Down here where I was adding some notes, I said abilities has all the features of the superclass plus more. Inheritance is a very important feature of Java because it allows programmers to reuse existing software. I could make a really good animal class, and then you could use the animal class and you could modify it, customize it just a little bit by inheriting from it, right? I could extend the string class to give it some new special ability that the string class doesn't really have. Now, I can't even think of a good example for why I would want to do that. Let's make a string class that's got a name, right? So class myString extends the string class, and all it's got different is that it's got a name, right? This is stupid. And it's probably going to give me grief that I don't have the right constructors and everything. We cannot inherit from final string. All right, so if you mark a class as final, I made a mistake on what final means. Final does not mean that the data is fixed. Final means that it cannot be inherited from. So up here, when I made my segment a final class, wherever that was, right here, a final class cannot be inherited from. We made this class final because we weren't planning on inheriting from it, but mostly just to get rid of a warning in the constructor. And there are probably better ways of fixing that warning than making the class final. So that's kind of like voodoo programming or something, or something like that. I clicked on the answer, let it do it, and I didn't know what it was doing. Right? I even got the definition of it wrong until I reminded myself. So a person, that's our superclass, our most superest of superclasses. Every customer is a person and they have an address. Every employee is a person, but they have a job ID. Every full-time employee is an employee and they have a salary. Every part-time employee is an employee, is a person, but they have an hourly wage. So inheritance terminology. Pairs of classes are linked together. The more generic class is called the superclass. The more specific class is called the subclass. We say that subclasses are derived from superclasses. Unfortunately, the terms superclass and subclass are misleading. The super could imply that it has more capability, right? And then the subclass could imply that subclasses have less capability, fewer features. But it's the other way around. The subclasses have more capability because they inherit, they extend the superclass and then give it extra features. We'll stick with the term superclass and subclass because those are the terms used by Oracle, but some people call them parent class or base class. And then some people call them child class or derived class. This terminology is incredibly common. Person is the parent class, customer is the child class. I may accidentally, while I'm lecturing, call something the parent class of the child class. I try to train myself not to because, you know, like it says, the Oracle way is to do it the way that we've learned so far. But the C++ way and a lot of other languages call them child classes and parent classes. So UML diagrams for inheritance hierarchies. Nah. Benefits of inheritance. Helps with code reusability. The superclasses code can be used for multiple subclasses. So you might get to write a whole bunch of functionality, put it into one class, and then just have the other classes modify that ability a little bit by extending it and then having their own custom features. So a programmer can use an existing class to easily create a new subclass. Supposedly you can have smaller modules because classes are split into subclasses. This makes debugging and upgrading easier. Well, I've known programmers who came from other environments that weren't object-oriented, like they came from a COBOL environment or a C programming environment, and this stuff drove them crazy. They did not think it was easier to split all your functionality into multiple classes, and I kind of tend to agree with that. But once you get your superclass working perfectly, then you can ignore that and you can start working on the subclass. And so then you can check it piece by piece. All right, do I have any homework cooked up for superclasses and subclasses? Let's go look. I may not. Well, poop. Let me stop the recording for a moment. I really just want to pause it and I don't. Sorry, I'm too scared to do that. Y'all watching are just going to have to accept the fact that I'm going to go digging around in last semester's assignments. Well, that's pretty generic. Angle class, arrays, arrays continued. See, when I just called it homework 11 without actually giving it a description of what that homework was, that's pretty dumb. Wish I hadn't done it like that. I'm smarter this semester than I was last time. All right, let's look at the goldfish class assignment. See if that makes any sense to assign. Take the following set of classes and add one more class. The new class is called goldfish. It extends the critter class. Sounds like I did the same example. It has a new member called water temp. Give it a parameterized custom constructor that allows the fish to be created like that. All righty. So that's a good enough idea. Let me go back here and note that the homework what kind of animal has no teeth? A bird class that extends animal Did I put teeth as one of the things in here? In my
Yeah, you
animal
did.
class? Okay, good. Its constructor should set that the animal has 2 legs and no teeth, right? Otherwise, and then its sound is to tweet, right? I guess we could make it a crow class, right? Its sound is to caw, like that. So really, it should not be too complicated to take the existing code here, which I will include, right? You're just going to need to add one more class, and its constructor is going to need to be modified to pass in 2 legs and 0 teeth rather than 20 teeth and 4 legs. Does that make sense? That's a pretty short assignment, but I think that that's okay. We all good about that?
Sounds good.
All righty. Let's make the Dropbox and be done for today.